Okay, I know you're frustrated that this video isn't about my dust collection system I'm designing. I really have made progress on that, but honestly school's just a hassle and I need to make this for school, so I figure I'll make a quick video about it, me building it. So let's freaking get to it. Alright, so a little background on this project before we get too crazy. I am in a physics class at the moment and it's pretty fun. So we have a project that we're doing to explore physics, and basically I'm building a cannon, an air cannon, a pressurized air cannon now that I have an air compressor, that will allow me to shoot projectiles with varying degrees of aerodynamic efficiency and see how different designs affect their flight pattern. So the question is, what am I going to build? Well, I need to build a pressurized air cannon. Well, how am I going to do that? That's a great question. So, the first things first, sorry, let me put it together. So this is a Schrader valve. Now, it's called a Schrader valve. It's quite interesting. You can see, if it would focus, you can see, if it would focus, alright, you see that tip there in the end? You may recognize that from your car. That's basically a one-way check valve. Comes down to this sort of bolt down section. And then you can see this washer here that I'm pointing out with my finger. And then there's a grommet underneath. So you've got a hole here, which your tire fills up that space. And then you've got this washer, and then this screws down onto it and holds that in place. This piece, the Schrader valve, accommodates a wide range of vehicles, which honestly it's meant for somewhat low pressure environments, which is okay because tires generally only have about 32 psi in them. But we'll also be using relatively low pressures, about 60 psi, which the PVC I'm using will be rated for about, I think, 100 and some, maybe 200 even. Alright, so now that we're down here, this is the basic layout. You've got the Schrader valve over here to pressurize this system, and then you've got a tube here with two adapters, and this will be PVC. This is just a prop pipe for now because ABS and PVC don't have a pressure holding fit together. And this is the other important aspect of this system. This is a solenoid which is used to regulate irrigation systems for houses. You can buy this at Home Depot. That's where I bought mine, about 15 bucks. And you put an electrical voltage here. It says 24 volt AC, but I'm going to experiment with this and see if I can put a DC voltage to activate it. And once it activates, it stops blocking the fluid back here and lets it pass through. Now, on the end of this, it came with an adapter. It actually came with two, but I didn't need it on the other side. It came with an adapter, and I'm going to use this adapter or another adapter and adapt it to a piece of PVC, which I will be able to, I think, fit paper towel rolls onto. And that will allow me to 3D print a consistent size of nozzle, and I'll be able to maybe print something at the back which is the same mass. Or just volume even, because it's the same density, I assume. Well, that's arguably false, but that's maybe honestly something to think about for a later time, just to get the center of mass correct. Really not right now, that's a tomorrow problem. So, we're basically done for the first day. Tomorrow I'm going to get an actual PVC pipe, and I'm then going to calculate the volume that this cylinder holds depending on the length of this PVC pipe. And past that, I will, for tonight, the only thing left to do is to experiment with this actuator and see at what voltage DC it may turn on if if it does all, honestly, at any DC voltage. Now, maybe I bought the wrong one, and that's quite possible, in which case I'm going back to Home Depot tomorrow anyways. And then I'll update you tomorrow. So that's the plan for now. I'll see you in the morning. Okay, it's a little cold, but it's the next day. So I went back to Home Depot twice before class, and now it's after class. And what I picked up was not only the correct 2-inch pipe, this is not the 2-inch pipe, but also a 1 1/4-inch pipe, as well as the adapters to get to the solenoid. This way, I figured out my fuselage body. I can use a paper towel roll, and I'll be able to sand this PVC pipe down a bit. But this has a very tight fit on this PVC pipe, right? So it has some defects here, but we use paper towels, so we can I can use a recyclable product, and it's pretty consistent. You know, why would they? You know, they maintain consistent manufacturing processes, and I can pull them out of the middle to obtain these. So this is an 1 1/4-inch pipe. It's, I think, 24 inches long, exactly 24 inches long, with my non-calibrated Milwaukee measuring tape. But then I've got 1 1/4 to 1 1/4 female, and then 1 1/4 male to 1-inch NPT fitting, which goes into the solenoid, which then, of course, comes to the other side, which brings me to the next thing that I got at Home Depot. Where'd I put it? Okay, here we go. This is what I got. It's some 2-inch pipe. And here we go. We're gonna cut it with the chop saw. I'm gonna take this outside. I'm gonna grab my chop saw, which is down there, and cut this. I want to figure out the volume of this, right? So I want to make this particular volume. I would like to make the entire thing, how should I put it, 1 liter or 2 liters, right? Some SI unit of volume, because that would make my calculations much easier. Now, the way I'm going to do this is by basically making a short section of this, 5 inches here. I've got 8 feet, so I can make it as long as I would like, honestly. Arbitrary length, right? Or maybe a length that I determine. I'll say 10 inches, why not? And then I'm going to measure the volume by filling it up to the with the solenoid, and then closing the solenoid, tipping out the water on the top, opening the solenoid, and then pouring it out into measuring devices. Now I'm going to use kitchen measuring equipment. Well, I don't know. Maybe I'll take it to my chemistry teacher who has graduated cylinders on Tuesday, but that's for next week. I'll have to use my least accurate measuring instrument, this metal rule, and I'm going to measure in millimeters, actually. Okay, so the arbitrary pipe length, first dimension, 149.0 or 0.1. I was going for 150, but that's going to be okay, just for my own calculations. Okay, so now we gotta assemble it. This is just a dry fit. It should be watertight, but I'm not gonna pressurize it or anything. Yeah, so I did some little testing. 6 volts DC turns the solenoid on, and that's wonderful. So I discussed it with my dad, the electrical guy, and he said that 6 volts might be the low end of that, and you might get, you might be in a range, so it may be better to use a higher voltage than that. As my battery decreases in voltage, it might be out of range or whatever. So I think I might use a 4-cell LiPo battery at 16 volts, and I might have to do some voltage regulation there. But here we go. Look at this bad boy. Ooh, spicy, spicy. Okay. Then we got this. Look at that bad boy. Ooh. Okay, so that's great. This looks amazing. Okay, dry fit, great. I think I should 3D print a mount for this, like this, so I can, aim it at maybe 45 degrees or whatever I decide. That'd be quite interesting. And then it could fulcrum from wherever I want it to. We actually don't need this top bit, firstly, just for this test. Do need this powered on. So what I'm gonna do now is grab a funnel. Very good. We've got a funnel, and we've got this. I'm gonna put this raw air, then I'm gonna put water down here, and we're gonna fill this all the way up. And I might have to activate this, so I'm gonna go get my power supply down here. I'm gonna bring it downstairs because I think that's probably the best place to do it. And we're gonna do it. So here we are in the corner. I've got my power supply here. I'm going to hold this. How am I gonna hold this? Here we are, just a few minutes later. My dad came down and we talked about this problem, and we talked about how we determine the cylinder size here. Now I'm still gonna fill this up with this canister up with water, but I just want to explain why I couldn't fill up the way that I wanted to just from the get-go. So if we look here, hopefully, okay, here we go. So these arrows actually point this way, right? And this was, you know, I purposely put this in here. This is not a mistake to put it backwards into the canister, but you can see that the water comes in to here, fills up with the water pressure, and then overflows. Now the reason that this is obviously, not obviously I suppose, because it took me a minute to figure it out with my dad, but the reason that this wasn't working out with all the water was because it was such a, there wasn't very much pressure, right? And I was sort of leaning it like this, so it was just sitting up here in the top. And I blew through the piece over here, and my dad activated the solenoid, and it did, you know, I was able to blow through it. So air will come through properly, and it does work. So now the step is to use a funnel and fill up on this outer circle, and then once I've done that, I'll pour it all out and see the volume that it takes up. Okay, so it's day 3. No product placement for them. It's day 3. It's about 12 o'clock here, and I've done a little electronics work earlier today, and ultimately it was pretty simple, so I'll just explain it. And now it's sort of the bureaucracy time where you gotta send emails and all that junk to the other important people in the project. So I'll explain to you where we are and what the next step is, so that I can give you a little update next week. So the last thing you saw was some testing with this solenoid, or I think at least. Or it was honestly probably trying to find the volume of the cylinder here that I'm going to compress. There's still water in it, hilariously, but okay. So basically, this cylinder, compressed cylinder, and then this barrel are both connected to this solenoid via this 1-inch NPT fitting. So what I discovered last night, or what I thought of last night, is I'm going to find the volume of this NPT fitting, then I'll be able to seal the NPT fitting, right, which is already on here as a 1-inch NPT fitting, and then I'm going to just seal this because there's actually water in here. Then I'll be able to fill up from the top here this cylinder, and figure out how much volume is in it and measure it in my chemistry lab. Hopefully that's an email I'm going to send, and I'm going to get a precise measurement for the volume, and I'm going to know the rate you know, of volume per centimeter increase on this cylinder here, and then I'll be able to expand it to whatever volume I'd like. Further from that, I can also attach both of those NPT fittings to each side of this solenoid and find the volume on each side of the solenoid when it's closed, which honestly is not terribly difficult to do. I just need to fill it up with water and measure it, and then subtract the volume of this NPT fitting, right? Because if I measure the volume of this and this, oh, that's leaking out. Anyway, so if I calculate the volume of this with the NPT fitting and this with the NPT fitting, I need to subtract the volume of one NPT fitting to, you know, make it the complete system there without going over. So I'll be able to find the pressurized side, and then I'll be able to do the same thing with the barrel and the other side of the solenoid. The solenoid does not have equal volume on both sides, as I understand it, but, or well, maybe it does. That'd be pretty good engineering, but I couldn't tell you honestly. So we're gonna find out, and then we're gonna see. Then I'll be able to calculate what pressure I want the. Or actually, honestly, here's where I should start with this calculation, right, is what force I want the rocket to launch with, right? Say 1,000 newtons or something, right? Okay, so just a quick interjection, future Kieran here. It's about 10 o'clock actually on day 3, so it's basically still current me, if you will. It's always current me anyways, because that's really how that works when you're recording something. But I didn't quite fully explain myself in the segment that I filmed earlier today, so I just wanted to re-explain it really quickly. So, the interesting calculation that I'm about to conduct, that I won't show in this video, I'll show it next week, because honestly I'm not about to, but I will eventually. Basically, I need to find out the mass of the rocket that I want to shoot, or determine the mass, if you will. And then I want to determine the force that I need to launch with to get a desired range, which I will arbitrarily determine based off of how badass it is and how realistic as well. And then I'll look at the surface area, or the cross-sectional surface area of the tip of the rocket. You can see this tube obviously is relatively small, but all of the force from the pressure of the barrel will be applied to this cross-sectional surface area here, because all of the forces that go from the inside to the out, you know, in this direction, relative to this tube and up and down, right, it's a circle so it goes outward, will equal each other out, ideally. And so, when the rocket launches, there will be a certain volume here, right? But just before the rocket launches, if you will, all of that volume, or that entire volume of gas will be stored in this smaller cylinder over here, right? So if this section, right, this barrel section, is the same volume as this pressure tank, there will be a decrease by half of the pressure when I open the solenoid, and the pressure equalizes between both of them because the volume obviously is doubled. So the pressure is decreased by half there. Now, I honestly couldn't back that up with a formula, and it's a bit too cold to really try and think that through. But once I figure out how fast I want, or how much force I want to propel off of this surface area here, alright, so if I need it to be 100 PSI, right, we're just doing PSI, but it's all going to be in SI units. 100 PSI in this big volume here, and it's going to decrease by some ratio of volume, it's going to decrease by some ratio of these two volumes here. By decreasing the barrel volume and increasing the tank volume, I can decrease the amount of pressure that I need to get into this cylinder in order to get the desired output pressure over here. And so I will be able to calculate that once I find out the volume of this cylinder here. and that's for a later date. But I just wanted to explain the next steps, or the multi-step process that I have to do to figure out the next sort of dimension, if you will, of this project. So now we'll go back to past Kieran, I guess. Today I did some electronics work, and basically I took a 4S LiPo battery. If we look back here, basically just a bunch of junk, but I'll get close here. So I took a 4S LiPo battery. So it's an FPV battery, honestly, but it works out. And then I've just taken a little XT60 connector. These are actually connected in series, but I just deleted the other connector there, turned it into a wire. And then it leads to this switch. This is actually a double throw, double pole switch, but I just connected to the two on poles, right? So now I can turn it either way to go on, and then if it's up, it's off. So on, off, on, off, on, off. Anyways, so that's gonna apply about 15 volts just to these two these two red and black wires here, which have no connection on them, I admit. I'm gonna take these two black wires, and then I'm gonna take the two, red and black wire and two black wires on the solenoid, and then I'm just gonna connect them up, and then ultimately I should be able to just switch it on and off with this switch, and that will allow me to, activate this air cannon. Moving forward, I need to write a bunch of emails, but then also I need to design the mechanism to move the rocket angle, right? So what I might do for that is I need to figure out where I want that to pivot, right? I might have it pivot right, somewhere in the center of this barrel. Ultimately, lessening the volume of the barrel is going to lessen the impact on the tank itself. So that might be advantageous to shorten the barrel. So perhaps I'll have to shorten this barrel. This is 24 inches right now, and it looks absolutely badass, but I don't think that this is the best, I don't think this is the best setup. Ultimately, I need to figure out where I'm going to be able to position this, by holding it in real life, because I have to be able to angle this reliably. I think I'll 3D print them out for these tubes here, right, just to clamp around these tubes, and then I'll make a wooden base, probably out of MDF or something like that, to just keep the rocket square to the ground, and then print out a template of angles to set the rocket to. That's about it. That's really all I have to say. Time to send some emails and all that bureaucratic stuff. See you next week.